Hello again. In this video, we will talk about randomness in real life and role of statistical models. So I start this lecture by a famous quotation by Democritus. Everything existing in the universe is the fruit of chance. So everything, according to his phenomena, according to his understanding, everything around us somehow relates to randomness. And in the beauty of statistics, that is what we account in statistical thinking through data. So we gather data, we somehow try to account for that randomness through statistical models or mathematical models. And then we visualize, we understand, we observe the behavior, we look for predictions. So that's what is the main objective of this whole quantitative research, quantitative analysis. Random phenomena in real life, well, we come across many different examples where we noticed random phenomena or randomness. For instance, if you toss a coin, you don't know whether it comes up as head or tail. So there is a randomness involved in this small experiment as well. If you roll a dice, there are six outcomes in total, and any one of them can appear on the top side of the dice. When you play poker, you have no idea what kind of card are going to pop up. In natural sciences, physics, most specifically in quantum physics, we talk about, actually quantum physics talks about probability a lot. Probability, randomness, chances, how to accommodate or how to account for chances, the behavior of electrons, protons. In genetics, we of course deal with a lot of issues related to randomness, DNA, protein construction and their behavior. Climate, well, weather is a very famous example for that. Every day we observe different climatic behavior, and in order to facilitate or accommodate the whole behavior of data of weather, we gather a data for some time span and then try to model through some appropriate models and utilize them for forecasting. And that's why it depends how good your model is and how appropriate your data is, of course. Then based on those two things, we somehow manage to come across good prediction or good forecasting for weather. In engineering, for instance, risk and safety analysis, we noticed randomness or chance associated with those experiments. In ocean engineering, when you build a vessel, so the quality of vessel depends immensely about the quality of weather, quality of waves in the sea. Somehow there are high waves, somehow there are low waves, and they hit every time they hit the vessels actually. And well, this is one example. Among ocean engineering, there can be many other examples. So in order to build a nice vessel or a strong vessel, so to say, we need to visualize, or we need to understand the behavior of waves, how big they are. And we all know that waves are completely random. So one randomness is associated with another property or another object. Economics and social science as well, currency exchange rates, stock market fluctuations, we hear about a lot about these things in daily newspapers. Insurance claims, all of these phenomena are associated with chances, with randomness. So I'm not going into detail about that page, but this is important for those who are interested in learning about random phenomena. So there's a website, www.random.org. If you really are interested in learning about randomness, you can visit that website and learn more about that. Statistics, a roadmap for this whole course, especially and also in general statistics, statistical learning. We talk about data collection. We collect data. I said big data because now we are actually living in the age of big data. We have huge data resources. We are struggling with data storage. We are struggling with data analysis, data mining. So first we collect that data and then we explore that data. So in general, it says exploratory data analysis because we draw some graphs, some basic primitive graphs, and we draw some, or we calculate some basic descriptive statistics like mean, variance, standard deviation, median, and mode, range, and many others, the basic primitive statistics, and then try to explore the pattern of the data. They are very primitive, but they're very, very useful in understanding the behavior of the data. And we can also think about any process or any experiment in a probabilistic way, like what happens in future. What are the chances that there will be rain tomorrow or snow tomorrow? And for that, or to answer those questions, we need a huge set of data. We need to visualize that data, understand that data, and then we need a specific or appropriate statistical model to build upon that data. And then that model can help us to predict or forecast values for that data or for that particular variable, if you're talking about weather or any other phenomenon. Then we draw some inferences. We consider several models, and we pick a model which is mostly suitable to that data. And there are ways how to select. Actually, there are criterions, and in this course we will learn something about that as well. Sometime we are interested in learning about relationships. As I said in my previous example, the big vessel, the ship, or the quality or the strength of that vessel depends on the wave height, for instance, or depends on the behavior of waves. So it means those two variables are correlated, are associated. So if we know some association beforehand, we should include that association in our analysis to understand the data behavior, to understand the process behavior actually, and to understand the whole situation more appropriately. So sometimes we have one variable behaving independently, sometimes we have more than one variables and they are associated with one another. So if we know any of these properties, we should accommodate them in our analysis. So for them, we learn about regression, simple regression when we have only one variable depending on the other, and in multiple regression when we have one variable depending on many other variables, for instance, or many other variables influencing one variable. We learn about the phenomena of correlation as well. How strong the dependence is, how strong the association is between or among the variables. So if we have those information before and if we have any clue about them, we go for incorporating them in our analysis. Some terminologies related to data. Well, data allows us to create a distribution. By distribution, I mean the behavior, the pattern, and explore descriptive measures such as means, variance, quantiles, skewness, kurtosis. You don't need to worry about those terms. We will be learning more in coming weeks. And data generally can be decomposed in two components, population data and sample data. By population data, we mean all measurements of interest, like all the registered voters in this city or in this country, for instance, all the students enrolled in this university. So if we talk about everything or all in general, we say this is a population of that particular variable. But for samples, we observe a subset of population. So instead of looking for all the variables in this university, I can say, okay, I can pick a sample of students enrolled in the master's program in this university or in the bachelor program in this university. So if I'm talking about your department, I can say students enrolled in your master's program in this department, for instance. So they are the samples of the whole population. They are the representative part of the population. Variable is another important phenomena in statistics or in statistical learning. So a property for an individual population unit that varies over time, that's what we call variable. there is a variation in that particular population unit. For example, something is going high and going low. That can be a variable. Weather data, for instance, it's completely variable. Every day you observe different weather predictions or different weather situation. Actually, stock prices are variables. Every day we notice different stocks. Sometimes it goes up, sometimes it goes down. Variables can further divided into two components, like independent variables and dependent variables. Well, by independent variables, I mean the set of variables that stands alone and does not change by the other variables. Independent or alone single-handed variables, so to say. They are one variable, they are not influencing by others, and they are not influencing others as well, so they are independent variables. Independent variables are less common in reality. Actually, usually we observe some kind of dependence from other variables as well. So dependent variable, again, on the contrary, is a set of variable that depends on other factors. For example, the variable usage of smartphones depends on education level. So here the variable smartphone usage is dependent while the variable education level is independent. So we somehow describe which of the variables are dependent and which of the variables are independent, and use them in a statistical model accordingly. This description is very essential while applying methods such as regressions. We will learn how we decide dependent and independent variables and how we use them actually in regression. Data, well, types of data, for instance, there are qualitative data and quantitative data in a big class, so to say. Qualitative, by qualitative I mean that provides information about qualities that cannot be measured. For example, gender, color, race. These are the qualities of the data. Quantitative data that can be expressed in numerical measurements like numbers, length, height, age. All of these, when we can account those variables in a numerical way, we say that they are quantitative data. Again, another class is discrete and continuous data. Well, by discrete we mean integer data, no decimal values. In a layman word, if I say, take a certain value such as number of chairs in this classroom, number of students enrolled in this course, number of students enrolled in this university, for instance, number of people living in this city, number of population or number of people living in the whole country, for instance, number of registered voters. For continuous data, we not necessarily talk about integers. They can be and they cannot be. And for them, the specific or the most common example is the height. So it can have decimal numbers. Well, for qualitative data, they are further categorized into nominal and ordinal data. Well, by nominal data, we say that attribute or nominal data simply describes the characteristics that some item or individual possess actually, such as players or player number in a football team, for instance, a specific number associated or assigned to a specific player, marital status, yes or no, pass and fail, categories like yes and no categories. All of those are the nominal data. They are attributes associated with something. And for quantitative analysis, we usually label those categories in 0 and 1 in some numerics so that we can use them in data. So whenever you come across with qualitative data with some attributes in your research or in your project, you just need to somehow decode them in numbers like codes 0 and 1. For instance, 0 is for male and 1 is for female, just to recognize those variables. For ordinal data, ordinal or ranked in as the word says, like in order. So when order is implied between individual or categories, it becomes ordinal data. For example, exam grades, A plus, A, B, these are the ranks assigned to assigned to some students, for instance. It often appears in marketing research where respondents are asked to express their opinions about something on a 5-point scale. They usually call this as a Likert scale. So if you are in a survey, if you ask about opinions about something, from a customer, and he or she can come across with 5 of these points, any of these 5 points actually: strongly agree, indifferent, disagree, or strongly disagree. So these are the ranks, these are the orders. You cannot change that order actually. By mean, strongly agree means the highest point, of course, and strongly disagree means that lowest point, of course, in understanding. Another categories are like interval data and the ratio data. By interval data, in which we not only know the order but also the exact difference between the values. For example, temperature with the Celsius scale, they can be defined at 2 specific points. For instance, say the freezing and the boiling point of water is separated by 100 intervals, right? And ratios are not allowed in the intervals because there is no such thing as no temperature. And that's why we don't say or we don't include ratios in the interval scale. For example, 20 degrees centigrade cannot be said as twice as hot as 10 degree. There are two different meanings for those two temperatures. On the other hand, in the ratio data, it is the estimation of ratio between a magnitude of continuous quantity and a unit magnitude of the same kind. For example, a ratio scale possesses a meaningful zero value. Well, there is a zero value to a ratio. Length can be zero for something, height can be zero for something, duration can be zero for something. So these are the 3 common examples in this ratio scale. And it is also logical to say that one object is twice the length of another object. And that's why we define length in a ratio scale, not in the interval scale. So when you will come across with the data collection, you will see that your data would be categorized in any of these four attributes, so to say, like the attributed data, the ordinal or nominal, the ranked data, the interval data, or the ratio data. So once we are done with this data collection, we will move on to learning about more important statistical methods or techniques to visualize that data. Thank you very much for today.